17C, number 2. 100 draws will be made at random with replacement from the box 1339. So 1339. We're going to be drawing 100 times. So my D equals 100. And just for practice, what is the sum of the box? One, 3, and 3, and 9 add up to be 16. What does 16 mean? What does that tell us? If you make 4 draws, you're expected to earn $16 or 16 points or whatever you're counting. Okay? What is the average of the box? Divide by 4, because there are 4 tickets in the box, and I get 4. What does that number tell us? On average, every draw is worth 4. Can you actually get 4 on a single draw? No. But over time, every draw averages about $4. Okay? So, if I draw 100 times, what is the minimum amount I can earn? 100. And how can you earn 100? What has to happen? You're supposed to get 1 every time. Is that very likely? No. So 100 is extremely unlikely, practically impossible. Okay? And then what is the maximum amount? 900. What has to happen in order for that to occur? You have to draw 9 every single time. Is that very likely? No. So our histogram, or our normal curve, is going to be based between 100 and 900, and both of those are extremely unlikely. So the normal curve will look something like this. Okay? B, how likely is the sum to be in the range 370 to 430? Well, first, I need to find the expected value. What is the expected value for 100 draws? Well, if I draw 100 times, and the average of the box is 4, then I should expect about 400. So I know that the middle of this curve is at 400. Okay. By about how much? Plus or minus the, what term are we going to do plus or minus with? What's that called? Standard error. Why is it not standard deviation? Well, they act the same, but the calculations are different. Why do we use standard error instead of standard deviation? Well, did we actually draw 100 times? No. So we don't have a list of numbers to create the standard deviation with. So we are predicting a standard deviation, which is the standard error, which means we expect to be off by about the standard error. Every time we play this game, there will be an error. The standard error is the expected error, not the actual error. The actual error would be the standard deviation, but we didn't play this game. We're only predicting what will happen if we do play it. So how do I calculate the standard error? Feel free to look at the wall. The SE is simply the SD of the box times the square root of the number of draws. So I need the SD of the box. How do I figure out the SD of the box? Got to use my calculator. So I go into Stat, Edit, I'm going to clear L1, and then I just put in the tickets 1339, and then I do a one variable statistic, and actually, if I would have done this at the beginning, everything I needed is right there. You have the sum of the box, you have the average of the box, and the SD of the box is 3. So the SD of the box is 3. What does 3 mean? I'll help you out. On average, the tickets in the box are 3 units away from 4, which is the average. So this is the average distance from the average. So on average, the tickets in the box are 3 units away from 4. Okay? Now, we need to use that to create the SE, so I'm going to plug 3 in there, and then I have to multiply it by the square root of D, which is 10. 100 square root of 100 is 10. So my SE is 30. What does that tell me? I'll help you out. If you play this game 100 times, you're expected to earn 400 points, give or take 30 points. Okay? Now, the question wants to know, how likely is the sum going to be from 370 to 430? Do we need to do any more statistics to figure that out? No, it's 1 SE, which means 68%. What if it wasn't 1 SE? Well, then we would need to do a shade norm. You'd find a z-score for the right and a z-score for the left, and then you would shade norm. Unless they're the same distance apart, and then you can just look the number up in the table. All right, number 3. You can draw either 10 times or 100 times at random with replacement from the box -1, 1. So my box has 1 copy of -1 and 1 copy of 1. And the choice is, do you want to draw 10 or 100 times? So letter A, to win $1 when the sum is 5 or more and nothing otherwise. So you win $1 if the sum is greater than or equal to 5. I want to do 100. How come? Okay. So when I have 100 draws versus 100 draws, which error is bigger? Which one will be further away from the average? Absolutely. So which one will be numerically further away? 100. How come? There are more draws. Okay. What about percent error? It goes that way. So let me put it in different terms. Are you more likely to be 5 away from average if you do 10 draws or 100 draws? 100 draws. Because the more draws you do, the bigger your error gets. But are you if you want to be 2% away, are you more likely to be well, let's say, let's do the same number. Let's do 5%. Are you more likely to be 5% away if you do 10 draws or 100? 10. The more draws you do, the standard error, or sorry, the absolute error goes up and the percent error goes down. Why is that? Because the error grows slower than the draws. We pointed that out last time. So the more draws you do, the further away from the average you're expected to be in absolute terms, just using subtraction, but the closer you're expected to be in percentage terms. Does that make sense? And why is that the case? Well, if you increase your draws by timesing by 100, So to go from, to go from 10 to 1,000, I increase by timesing by 100. But my error gets times by the square root of 100, which is 10. So if you multiply your draws by 100, your error gets 10 times bigger, which is slower than the number of draws, than the way the draws are increasing, which means the percent error goes down. So you need to remember that. The more draws we do, the further away we are from the average in absolute terms, but the closer we are to the average in relative terms, as far as a percentage goes. So letter A is asking, or is A asking absolute or relative? Win $1 when the sum is 5 or more and nothing otherwise. Is 5 an absolute number or is it a relative number? Absolute. So if we want the absolute number to be big, we want to choose lots of draws. So the answer is 100. Okay, B, to win $1 when the sum is -5 or less and nothing otherwise. How does that problem differ from the first one? It's just negative. So it's the exact same problem on the other side of the average. So we want 100. To win $1 when the sum is between -5 and 5 and nothing else. So do we want the absolute error to be big or small? Small. And if we want the absolute error to be small, I need to choose small draws. So if you draw 10 times, how likely is the sum going to be between -5 and 5? Very, very likely. That was C. So if you draw 10 times, the only way to lose is to get 9 of one number and 1 of the other. If you get 8 of one and 3 of the other, your sum is going to be either 5 or -5. Okay? If you draw 100 times, how likely is your sum to be outside of that 5 range? Much more likely. Does that make sense? Okay. And 5. Suppose that in 1 week at a certain casino there are 25,000 independent plays at roulette. On each play, the gambler stakes $1 on red. Is the chance that the casino will win more than $1,000 from these 25 plays closest to 2, 50, or 98? So let's go back to our box. If we bet on red, what's in the box? 18 copies of 1 and 20 copies of -1. So I know that the sum of the box is -2 and the average of the box is -0.052. I even know the SD of the box. The SD of the box is really close to 1. Why is it really close to 1? If I draw the histogram, how many -1s are there? Well, there are 20 of them. And how many 1s are there? There are 18 of them. So the average is, here's 0. The average is right there. How far away are those from the average? Like 0.98, 0.99. Okay. I don't want to plug this into my calculator because I would have to put 18 1s and 20 -1s and then do a one variable stat. Now, in a future section, there's a shortcut, which you guys don't know until the next section. So I'm going to say the SD of the box is 1, and that will be good enough for today. Okay. So we are going to play 25,000 times. So D equals 25,000 times. What is our expected value? How do I get that? Well, I need to do, you're expected to lose 5 cents per draw times 25,000. So negative 0.0526 times 25,000. What does that number mean? You are expected to lose $1,315, which means whenever a casino has had a total of $25,000 bet on red, that casino will win $1,315. Now that doesn't matter if they bet using $1 or if they bet using $10 or $100. For every 25,000, the casino will win about 1,300. Okay. Now what do I do? Well, I draw my normal curve. The average is negative 1315. What do I want? I want to know from negative 1,000 to the left, right? Because it says, what is the chance that the casino will win more than $1,000? So this. So I need my standard error. So I'm going to take the ST of the box, which is 1, and times it by the square root of 25,000. So the square root of 25,000 is 158. What does that mean? That is my standard error. So in this case, if you bet $1 on red 25,000 times, you're expected to lose $1,315, give or take 158. So I need to calculate this distance. So 1,315 minus 1,000 gives me 315. And then divide that by 158, and I get a z-score of 2. So I need to shade norm from from negative 5 to 2. And, oh, I don't have my thing in the right form, but that's okay. It'll still give me a percentage. Well, maybe not. My window's way off. I get 0.977. Which means the casino has a 98% chance to win $1,000 or more if you play 25,000 times. Okay. Now, we didn't need to do all that. Right? Look at the answers. Is the answer going to be 2%? No. No, because the casino has a really good chance of winning. 50% doesn't make sense. Why is that? So they are expected to win 1,315. The chance that they win more than 1,315 is 50%. Right? It's the left half of the normal curve. So this right here would be 50%. So it had to be 98%, but I just wanted to make sure you knew how to calculate and use the standard error. All right. 6. Do we do 6 and 7? Just 6. Suppose that one person stakes $25,000 on one play at black or red in roulette. Is the chance that the casino will win more than $1,000 from this play closest to 2%, 50%, or 98%? So if you only play one time, there are only 2 outcomes. What are they? Lose $25,000 or win $25,000. Okay? And the chance is not 50, it's actually going to be the casino has a slight edge. right? With one bet, the casino has just a little bit of an edge, a 5% edge. So it's actually about 45% that you win and 55% that you lose. Okay? All right. We're done with C, correct? What